Hi chemists, it's Miss Onay. Hopefully you guys are having a great late arrival. Maybe you got some yummy breakfast this morning. However, I'm out for the day for meetings, so I didn't want you guys to miss out of the fun in chemistry, so I have created another flipped video for you. And today we are talking about target number 4. So behind me, you guys, you can see target number 4. This is what we're going to be working on today. So the first thing I need you to do is open up your packets to page 22, okay? So if you need to hit pause, please go ahead and do so, but we're going to get started. So target 4 says, I can balance chemical equations to support the claim that atoms are conserved during a chemical reaction. Why do I love this target? For one, we are using scientific lingo that we have been talking about since like weeks ago. For example, it says, I can balance chemical equations to support my claim that atoms are conserved during a chemical reaction, okay? So our claims and our using our data for support, that is not just a thing in the past. We still use it, and that's why we look at target 4. We are using evidence by balancing an equation. We will be using that evidence to show that the law of conservation is true, okay? So if you guys are on page 22, you guys are looking at this first chemical reaction. So we have been introduced to 1 or 2 chemical reactions just as either a capture question or something that you've seen on your labs, but this is the first time that we're going to be talking about how to actually read a reaction, okay? So this might seem very obvious, but we need to talk about it. What is a reactant and what is a product? So if I'm looking at this equation, my reactants are going to include NaOH and HCl. Everything to the left of my arrow, okay? These are my reactants. Okay? So on your paper, it asks for you, what are the reactants? You should put NaOH and HCl, okay? Which leads me to, what are my products? I'm sure you guys can take a guess there. That leads to NaCl and H2O. These are my products. So how do I know? And how do you know? It's because of this fancy little arrow right in the middle of my equation. This arrow tells me everything, okay? So it says, how do you state an arrow? An arrow is not just there to show you the direction of the reaction. It actually means something. An arrow means to produce. Okay? So if I were to put this reaction into a sentence, I would say that sodium hydroxide can react with hydrochloric acid, that's what HCl is, to produce sodium chloride and H2O, which we all know is water, okay? So that arrow means to produce, okay? It doesn't just mean our reaction is going to the right or it's going to the left. That arrow is very purposely put somewhere to show you that these reactants together, they produce these products, not vice versa, okay? So we are going to move on. Now that you guys got your lingo down, you should know reactants, you should know products, you should know that the arrow means to produce. So now we're going to start with our next equation. And before we do that, we need to talk about why equations are balanced, okay? So why would equations be balanced? This is kind of what we talked about in the beginning of our little chit-chat. Target 4, equations need to be balanced because of the law of conservation of mass, okay? Because of the law of conservation, we balance equations, okay? The law of conservation tells me that the total combined mass of reactants should be equal to the total combined mass of my products. Okay, so this is the reason why we balance equations, and it is all due to our fancy law of conservation, okay? So you can all say thank you to them. So hold on, my screen just went a little bit blank. 1 second. All right, so we are going to go ahead and continue, and we are going to start with our next equation. So hopefully you guys got this down. If you don't, hit pause, okay? All right, we are starting with our next equation, which they give you on your piece of paper. That equation is 2H2, and there's this fancy G here, plus 1O2, and another G. There's my fancy arrow, which means to produce 2H2OL. So, on your paper, it asks for you for the coefficients, and it also asks you for the phases or the states. So in order to do anything, I need to teach you the phases or the states that you might come across in a chemical reaction, okay? So the first one that you need to know, you guys should just put this like in a box somewhere on the side. The first one you need to know is G. H2, O2, what do you think those are? Those are all gas, okay? If you see G, that means that that reactant or that product is in the state of gas. L. H2O is an L. Can you guess? Liquid. Good. S. If you see an S, that means that it is a solid. And then if you see an AQ, what that means is it is aqueous. Okay? So we will talk a little bit more about aqueous solutions as we go on, but for now, I just need you to know G is gas, L is liquid, S is solid, AQ stands for aqueous. So let's continue right on in our packet. So it asks for the coefficients, and it asks for the state for the reaction that I have written down right here, okay? So, coefficient, what does that mean? The coefficient means the number in front. I've got a number here, got a number here, and a number here. So, the coefficient for H2 is 2. That goes with H2. The coefficient for O2, 1. The coefficient for H2O, 2, H2O. Now, let's talk about the states. What is the state that H2 is in? It has a G. That means that it is in a state of gas. Okay? O2 has a G, state of gas. Last but not least, as you guys would have guessed, H2O has a state of L, meaning it's a liquid. Surprise, surprise. Okay? So, everyone should have this part filled out in their packet. You're about halfway through page 22. Okay? This is where we start to get tricky and we start to count atoms to make sure we are following the law of conservation, which is the whole reason why we balance equations, okay? So, we are going to get ready to count some atoms. So, we are going to check what is considered to be an atom here. What's one atom, okay? When they say count your atoms, what they mean is pretty much count your elements, okay? So, H is hydrogen, that's an element. It's also, you can have an atom of hydrogen, okay? So they say count your atoms. How many atoms of hydrogen do I have on my reactant side? Okay? Just on my reactant side. So I'm just looking right here. On my reactant side, I should have how many hydrogen? Okay? This is tricky. The answer, you should have 4 hydrogen. How did I get that? There are 2 hydrogen here. That's what our coefficient, that's what our subscript tells us, right? But then we have a coefficient. If you have a coefficient, you multiply, okay? You multiply it. That means you have 2 molecules of H2. If I had to draw 2 molecules of H2, I would have, here's one of H2, here's another of H2. Together, how many hydrogen are there? 4, okay? So that might be a little bit confusing right now, but we will get more in depth, so don't worry yet. So I have 4H. How many oxygen do I have? I have a coefficient of 1, and there's just one O2 molecule. If there's just one O2 molecule, then I know that there must only be 2 oxygen. Okay? Now, we are going to move on to the products. According to the law of conservation, it would make sense that I should have the same amount of reactants as I do products, but let's just double check. So, if I go to my products, I have 2 H2O, okay? If I had to draw H2O, I would say here's H2O. Here's another H2O. Okay? In one H2O, there are 2 hydrogen and there are 1 oxygen, okay? So in total, how many hydrogen do I have? I have 2 here and I have 2 here. That must mean I have 4, which, check mark, that matches up here, okay? How many oxygen do I have? In both H2O, there's only 1 oxygen, 1 here, 1 here. So I should have a total of 2 oxygen. Check mark, that matches, okay? So we just made sure that this little equation here, that this reaction, that this follows the law of conservation. Does it? Yes, you bet, okay? So hopefully, so far you're feeling okay. Now we're going to actually talk about how you can count atoms when things get a little bit tricky, when you start to see parentheses, when you have a coefficient and you have a subscript and you have parentheses. So we're going to break it down right now. So if you don't have this, make sure you hit pause and get what you need. Okay. All right, we've got a clean slate, ready to start again, okay? So we are at the bottom where it says count the atoms in each compound. This will be our biggest focus today. You will count atoms and compounds. You will do a practice sheet, which is page 23, while you're in class, and then there will be homework, which I will touch on in a little bit, okay? So we have count atoms in each compound. That is my direction. Count atoms. The first compound that they give me is Mg, parentheses, NO3, and then 2. We know what this is, right? Because this is an ionic compound. I know this because Mg, we know that is a +2 charge, and then NO3, we know that's a minus charge. That's how they get MgNO3 too, okay? So we are not trying to name it. We're not trying to trick you into anything. We literally just want to know how many atoms of each element are there. How many atoms of magnesium? How many atoms of nitrogen? How many of oxygen, okay? Now, this is tricky because we are introduced to parentheses with a subscript after, okay? So this is the rule when you have a subscript after the parentheses. If you have a subscript and you have something in parentheses before it, that subscript applies to everything inside here. It applies to my oxygen and it applies to my nitrogen, because basically what I'm saying is that I have 2 NO3 molecules. That's what I'm saying. So what this is, this 2 will carry over to the N. There's 2 nitrogen, and it will carry over to the O3. If there's already a subscript there, you multiply, okay? So 2 times 3 is 6. Are there 6 oxygen? There's 3 here and 3 here, that's 6. Okay? So, take a second, let it process. If you have a subscript outside of a parentheses, that subscript applies to everything within the parentheses. It does not come over here to the magnesium. Okay? So, how many magnesium atoms do I have here? There's no subscript, there's no coefficient, so that leads me to say that there is one magnesium atom. Now, how many atoms of nitrogen are there? There's no coefficient here, so maybe I would have said 1 originally, but there is a 2 subscript out here that applies to it, making that N2, so I should have 2 atoms of nitrogen. And then I have O3, but there's a 2 out here, so 3 times 2, I should have 6 oxygen. Okay? That is how you count atoms with the parentheses. Not too bad, right? I'm actually going to give you a practice one to count with some parentheses. Let's look at Ca3PO4 2. Okay? This one is a practice, okay? This is not in your notes. So the atoms that I'm looking at are calcium, I've got phosphorus, and I've got oxygen. First thing I have to decide is where do these numbers go? I have a subscript next to calcium here, and that is only for calcium. There's a lower subscript of 3, which tells me there are 3 calcium there. Then I have this 2, and warning, it's outside of a parentheses, meaning it applies to every element within that parentheses. So this 2 applies to the O, and it also applies to the P. So how many phosphorus are there? There's not 1, but this 2 comes in. There are 2 phosphorus. And last but not least, how many oxygen? If there is already a subscript in the parentheses and you are bringing this one in, you multiply. So you should do 4 times 2, which gives me a total of 8. Okay? Hopefully that helps. All right, now we are going to move on and we're going to do one more compound, and then you guys will have some time to practice, and then I'm going to give you some homework, okay? So our last compound, it's in your notes on the bottom of page 22. That compound is 3MgNO3 2. So I need to count the compounds within here. First thing I need to write down is what atoms are in here. I've got Mg, I've got N, and I've got O. Those are my 3 atoms that are within that compound. Now, we're pretty much experts here, right? We know how to do and deal with this outside little subscript. However, now we have a coefficient as well. So here's the deal. Here's what I think of when I'm trying to decide how many atoms. If you have a lower subscript outside of parentheses, it goes under to all the elements within the parentheses and only within the parentheses, okay? But if you have a coefficient, this big guy in front applies to everybody. He goes on top to every single person. He goes to Mg, he goes to N, and he goes to O. Whoa. Okay, so this is a lot. Let's think about it step by step. So 3, I want to find out how many Mg. The 3 goes to my magnesium. Is there any other subscript that I should worry about? Nope. So there's 3 magnesium. Now, I've got nitrogen to worry about. This little guy comes in here, you always do the one, and he becomes 2 nitrogen. There are 2 nitrogen. However, this 3 multiplies by everything. So imagine that this is N2 now, and you have to multiply that by 3. 3 times 2, 6. Okay? Then we've got oxygen. This one is a triple whammy. I've got two subscripts here, and I've got this coefficient. So the first thing I have to do, I can't just bring the 2 in and say it's O2. I already have a coefficient there, meaning I have to multiply those together. So I multiply 2 times 3, that becomes 6. But then I've got this big coefficient in front that also multiplies my 6 original. So 6 times 3, 18. So let's double, triple check that this is right. There are 3 compounds of MgNO3. So if I were to write out all of those, I've got MgNO3, 2. That's one of them. Then I've got the second, MgNO3, 2. Then I've got the third one, MgNO3, 2. How many magnesiums are there? 1, 2, 3. Good to go. How many nitrogen are there? If I were just looking at this single one, we know the 2 would come over here to my nitrogen, and then I have 3 of them. So 2 times 3, 6. How many oxygen? If I were just looking at 1, 2 would go to 3, and we would say 6, but there's 3 of them. So I have 18. Okay? So I know that's a lot, but we are going to stop there. We're not going to do any new information. So I'm just going to do one more practice one with you that has parentheses and a coefficient, and then you guys will move on to practice page 23. Okay? So the one that I'm going to do for you is 4Cu, parentheses, NO3, 2. First thing I always like to do, if you get confused, then you better draw those arrows. So my small subscript after the parentheses only goes to the things within the parentheses. That's it. My big coefficient in the front, however, goes to every single element within the compound. So let's start with Cu. We have nitrogen and we have oxygen. How many copper do I have? There's no subscript, so I just take 4 and I say there are 4 copper. How many nitrogen do I have? Bring the 2 here, that would be N2, but I also have to bring the 4 over, so that should give me 8. Oxygen. 2 comes to the 3 here. 2 times 3 is 6. But I also have to multiply that 6 by 4 to get a total of 24. So don't freak out. I just want you guys to get some practice. So for the remainder of the period, you have a couple things that you need to do. Your homework is to do page 23. This is what it looks like. I have the answers that we will go over tomorrow, okay? And then your other homework is this back page. So if you flip to 24, it's this top part where it says chemical changes in matter. Just go to the half part with page 10. These will take you no time. So don't freak out and don't be upset that you have homework, okay? Literally, you have page 23, which will take you no time, and then half of 24, okay? So you guys have the rest of the period to work. Use your peers as a resource. Email me with questions if you have any, and I hope you guys have a great late arrival, and I will see you tomorrow, okay? Bye, guys.